So, speaking of math, I tell you, I'm ready for it. Are y'all ready for it? Let's all be ready for it. Problem of the day time. Let's see what we've got. This one's a little bit different than anything we've seen on here before, isn't it, my friends? Change the base 10 number, 89, into its corresponding number in the base 5 number system. Woo! That sounds a little crazy, doesn't it? Base 5, base 10? Some of you are going like, I didn't know there was any bases in anything. Well, base 10 is what we run ourselves in quite a bit, but there are some things that base 5 can come in handy with also out there. So let's take a look and see what this is about. So we said we're going to start with a base 10 number to its corresponding number in the base 5 system. That number we chose was 89. So let's just start off and think about what 89 is about. If you were to look, and by the way, this is a base 10 because we don't mention that it's some other base, all right? We just basically, that's the default. That's where we go. If we put a number in there, oh, it's base 10. But look at what happens here. The whole point of 89 is basically saying we're having 80 plus 9. And if you remember back in, oh my goodness, back in first and second and third grade, maybe even kindergarten, you maybe learned this. This is called the ones place, and this is the tens, because 8 times 10 would get you the 80, and 9 times 1 would get you the 9, and you'd add 80 plus 9 is a nice way to break this down, and you got 89. Now again, this is 9 ones, 8 tens. And then we got a little bit further along in the math systems, and we started thinking, oh, you know what? That's like 10 to the 0 to get a 1. It's like 10 to the first power to get there. And if you want to go to hundreds, guess what? It was 10 to the second. So what we're going to do, we're going to take this number 89 as you see it. Just hang on with me. And we're going to break it down into, you remember how we said we had ones, then we had tens, then we had hundreds. Because they came from what? This was like 10 to the 0. This one was 10 to the 1. And the next one would be 10 to the second. And you go on thousands, would be 10 to the third. You get the idea. You'd raise your powers. We'll make that a little bit bigger for those of you who are just joining us. That's a 1, and that is a 0. I just realized sometimes we don't make our numbers big enough on here. Now, what's going to happen over here in the base 5 system is we want to look at what? 5 to the 0, 5 to the 1 power, first power if you will, 5 to the second will give us, because we're going to try to break down 89 into numbers that will fit in here. By the way, in the base 5 system, you're only allowed to use the digits 0, 1, 2, 3, and 4. Is that not cool? So you're like, gosh, what are we going to do? So in other words, once I get to the example, once I get to 5 units, that basically means I have a 5 and no ones. All right, so it'd be 1, 0, base 5. That's what we'll call it. Not 10, but 1, 0, base 5. So as we go through this, I want you to see, what are we going to do? Well, we know 89. What would happen if we went to 5 to the third? 5 to the third, 25 times 5 is going to be 125. So this is like 125. This is like 25. This is like 5. And this is like 1. So what we want to know is how many 25s, because that's going to be filling up this position. I can't go to 125. I've only got 89 to work with. All right, so everybody follow that? I can't pull 125 out of 89. It's not there. But what I can do is go along here and divide this 25, which by the way is going to be like what hundreds place was in base 10. This 25's place is going to be the same position in base 5. Obviously not the same value, but the same position. So here we go. Ready for this? Like I said, this is going to be crazy. We're going to divide that 25 into 89. We're going to see how many times will it go. Well, from what I can tell, it's going to go 3 times, and 3 times that leaves me with 75. Now you say, Ernie, what's this about? And we have what left over? It looks like 14. So at this point, I have a 3 in this position. Remember, we're not going to use that one, all right? So I've got a 3 that's going to go in this 5 to the second position as we start writing a number out, okay? Now, what have I got now? I've got 14. So I want to take my next digit, which is 5, and I want to divide 5 into 14. How many times will it go? All right? And how it does, how it works, goes 2 times. 2 times 5 is going to give us 10. We got a 4 left over. And now, guess what? That 4 is going to fit perfectly right here. By the way, what do? We put a 2 right there, and then we put a 4 right here. So my final answer on this one, just ran off a little. Okay, so we'll put it 2, 3, 4, base 5. Now, is it going to work? Is it going to work? 3 times 25, let's check it back through. We'll just use the notation. We know that 3 times 25, there we go, plus, what do we get? 2 times 5, plus our 4, and look what happens. 75, 10, plus 4, remember how we worked there, and those add up to give us, goodness sakes, you got it, 89 back into the base 10. So that's a pretty cool little manipulation. Can you do other bases? Certainly you can. Maybe you want to do base 2, which is what the binary code used to be all about with computers and such. But that gives you a chance to see base 10 going to base 5, and then we went right back, okay, back to base 10. Going back to base 10 is a lot easier, isn't it? So anyway, thanks for tuning in on that one, and an interesting twist of problem today.